So the first one, it would be just falling downwards.
Yes, the motion of the stone. So I think, and is there anything you could say about its speed or anything like
that? Will it be falling at 9.8 meters per second?
Yes. It will be, its acceleration will be g, 9.8. Okay. How about b?
Does that mean B will be falling at 2G?
I believe it will still be g, because we didn't know the speed for the weight for the first one, the mass.
Oh, okay.
And so I think the acceleration is just g. Okay, how about c?
Would it fall still at 9.8?
Use our hand velocity of u vertically. What effect will this have on the motion of the stone? She now throws the stone over the edge. I think it will be, that will just be added to the acceleration.
Okay.
So this one I think will accelerate downwards at g. This will also be the same, and then this one will be u plus that g. Let's see. That was that. Okay, so if air resistance is ignored, yeah, the only force acting on the object is its weight. Its acceleration is g. Yes. Okay, how about A2?
Would we have to work that out through a Suvat equation?
You could, yeah.
So could we use v squared equals u squared plus 2as?
We don't know distance. We don't know s for displacement.
Would it be the v equals u plus at one over 2?
Yeah, not over 2, just v equals u plus at.
Okay. So is that just 9.8 times by 2?
Yep.
So that's 18.
So
oh wait. That's 19.6.
19.6 meters. Yep. Downwards. Okay, how about these?
Would the first one be 24.8?
Let's see. And the time is 1 second. So if I go to my v, solve, I'm getting 5.2, but I did this a slightly different way. Let's see. She throws the stone upwards. Calculate the velocity of the stone after 1 second. So if she throws it upwards, so what was u?
That's 15.
And what is a?
Is it minus 9.8?
Yes.
Not positive.
Yes, because it's acting in the opposite direction.
So yeah, would that be 5.2 then?
Yeah. Okay. How about B?
Is that minus 4.6?
Yep. And I think we get the idea. Let's see.
Yeah.
Let's think about this though. The velocity. So what do you know about minus 4.6? What direction? What direction is that going?
It's going downwards.
Yes. And so the other one was positive. Now after 2 seconds, it's negative, so it's going down. Oops. Okay. Yeah, 5.2 upwards, 4.6 downwards. Okay. How about this one? Start from A.
So the velocity would be positive while he throws it up. And it'll have a point where it stops midair and then it will start falling, so the velocity will be minus.
And when it stops, what is its velocity?
It'll be 0.
Yes, and then in the middle, its velocity at the top will be 0. How about that was B? How about C?
B will be 0.
C?
C. Should the velocity be smaller?
I think it will be the same but negative. So if he throws it up with a velocity of 15, when it comes back down and lands in his hand, it will be minus 15 if the distance is exactly the same.
Okay.
So I think it'll be like same but negative. Okay, go
on. The velocity time graph would be a negative parabola.
Yeah, I think so. So it's going to be, well, if we take it as 0, then it might be start from 0, go back down to 0. And that's a velocity. Hang on, that's a velocity time graph. It's velocity. Okay, a displacement time graph.
Wouldn't the displacement be 0?
So at the start, the displacement is 0. Let's see. So
because obviously when it hits the maximum height, it falls back down. So would that displacement end up as 0?
So maybe, yeah, because it had a positive displacement, then it goes up, then it comes back down to 0. So let's think about this velocity time graph. Is that then, if its velocity won't be 0 actually. Let's say if it had an initial velocity of 15 or something, then it would start a bit up.
Will it be a graph that will start at 15 and go through the x-axis to minus 15 as time goes on?
So it's velocity. Yeah, so I think that will be, let's say it's there, and it might look something like that, is it? And if that's,
I think so.
If that's 15, then let's call that 0. Let's call that minus 15. Will it be a straight line or a curve though? That's a straight line. That's what it should look like. Yes.
Okay.
Because it constantly has gravity acting against it, and so it's always going to be slowing down actually. Yes. And so it's 0. Yes, let's say that. So that's minus 15. That's plus 15. Yeah, it's always got gravity acting against it. That's velocity time. This one is displacement time. Yes, so velocity is straight line, displacement curved line. And they... Okay, so they're assuming that the hand is at 0. All right. Any questions there?
No.
Okay, let's try this one. Oops.
Would we use s equals ut plus a half at squared? Because we don't know the final velocity, do we?
So we want s. What we don't know v. What else do we know?
U would be 0. We would have the acceleration is 9.8. And we know t is 4
seconds. Yes. And so s is equal to ut plus a half at squared. And you'll just sub them in. I think you'll be okay for that one. I think you're good. Okay. How about this one?
So we're finding out s. We know u is 20. We don't know v again. Would the acceleration for this one be minus?
Yes.
So then minus 9.8.
Yeah, and that's because the u is positive. But actually, what height do we have to find? The height of what?
The maximum height.
And what?
So we have v is 0.
Yes. So what would you do here?
Could we use b squared equals u squared plus 2as?
Squared plus 2as. Yeah, and I think you'll be fine for that. And what type of calculator do you have, by the way? Do you have graphical?
Yeah.
Okay, so do you use the solver?
I've never used that one before.
So I think it'll be worth trying it. So you have to use different things. But if you go to menu equation, which is A, and then choose F3, which is solver. So
Yeah.
Menu A, solver. So you can put in v squared equals u squared plus 2as. What might help is if you press shift and then alpha for alpha lock, and then you can put them in a bit quicker. So v is 2, and then maybe it won't be quicker. We'll see. I'll have to do the v squared. Okay. Let me try again. Shift alpha lock u. See. No. It's quicker for the last bit. Plus 2
Okay.
as. S. It's just so you don't have to keep pressing alpha. And then I'm just going to put in these squared. Oh, I have to take off that alpha lock. Yeah, maybe that alpha lock isn't the best. And so do you have v squared equals u squared plus 2as?
Yeah.
So you press equals and then just put in the values. So we said v was 0, u was 20 equals a is minus 9.8. And s is, so when you've put, why did I do that? A is minus 9.8. And then you go on to S and press F6 and it should solve it for you.
Oh, so it's 20.4.
Yeah, and so that can make things a bit quicker, especially if you're doing lots of these, and in one question you can just, you know, change them around a little bit. So there you go, 20.
Okay.
20.4. Okay, how about this?
So we know U. So that's 12. Would the final velocity V be minus 12?
Well done.
So does that mean the acceleration's 9.8?
You tell me.
Is the ball falling back down?
Yeah.
So yeah, I think it is positive 9.8.
So you know the way we said U is 12?
Yeah.
So if this is thrown upwards, then we're resolving upwards. And so we're taking up to mean positive. So
the acceleration would be negative.
yes. You could take, if you were to resolve downwards, you could say that V is 12, A is positive 9.8, but then U would be negative 12. And you would get the same answer. You'd have to swap them around.
Okay. And we're trying to find T. And we don't know the distance, do we?
No.
Could we use V equals U plus AT again?
Yes, and that's the easiest one to use. And my guess is you'll be fine with that. They used this one. U is, they did it a worse way, I believe. They used displacement. They did a much worse way. Let's just make sure for this one. And so, I'll just use my solver. So we're doing V equals U plus AT. We said V is negative 12, U is 12, A is minus 9.8, and we solve the other one, and we get 2.45, and they get 2.45. Okay, our way is much better.
Okay.
So what puts you ahead of them is what they did was they said V is 0, and then they doubled their answer. Your way is much better to just say it's minus 12.
Okay.
Let's see this one. Okay, how about this?
So if we were to draw a diagram,
Okay.
would we take the first amount of distance as the 1.2 meters
Okay.
and then use that as like a projectile?
Mm-hmm.
So we know U is 2. Does that mean V is minus 2?
V will be minus 2. So you know the way it's thrown from here?
Yeah.
And it goes like that. V will be minus 2 here.
Okay.
Where do we want the time for? Where will the ball be for the time that we want? Or the coin, sorry.
When it hits the floor.
Yeah.
Okay, so we can't do V for that.
Mm-hmm.
Do we need to find out the maximum height it reaches and add that?
Well, we'll see. Is there anything else you could say about S?
It'll be X plus 1.2. If we take the height that it travels from the hand as X.
What we could do is say that the height it's thrown from, if we consider that to be 0, then the height that it lands at would be what?
0.
So that would be at the red part. What about down here?
Would it be minus 1.2?
Yeah, minus 1.2. And so this is the thing that we're concerned with. So this is what we want. And so at that point, when it hits the ground, we know its displacement will be minus 1.2.
Okay. We know A would be minus 9.8.
Yeah.
And T is what we're looking for.
Yeah.
Could we use the S equals UT plus half AT squared?
Yeah. AT squared. So do you want to try? Equals.
I used a solver.
Okay, what you get?
It was a negative number, so I don't know if they've done something wrong.
I think you did it right. There's I just noticed there's a trick to this. So I happened to get the correct one. It's because we have t squared, so there's 2 answers. And so this one might be better to solve using the quadratic solver.
Okay.
And so how would you solve that? Oh, so for that you would just press exit and choose polynomial degree 2.
So we know that'll be minus 4.9 t squared.
Yeah.
We've got 2t, and then you can have plus 1.2 equals 0.
Mm-hmm.
I've got 0.74
Yep.
and the other negative, which I got on the solver.
0.74 seconds. Yes, because you won't have negative time. And my one happens to get the 0.74, 0.739. It's just to do with the initial value that you start with. So if you start with, let's say, a big positive number, I think you'll get the positive answer. If you start with a small negative number, you'll get the negative answer first. And then how would you do part B?
So if we used could we use the s equals a half times u plus v times by t, and then we can solve it for v? Or could we use v equals u plus at?
Yes, and both will work now that you have what t is. So you could, probably the easier one is v is equal to u plus at, but actually if you're using your calculator, then they're both the same. U plus v over 2 times t, both will work. Yes. Okay. Yeah, any questions there?
No.
Okay, so the important bit that made this much easier is that s is minus 1.2, and so we didn't have to break it up into parts, and so sketching the little diagram helps. Okay, let's try this one. The particle is projected horizontally. Okay, how about this?
Is it 9.8?
That would be, you're thinking of vertically. This is horizontally. So this is across.
Does it not have any acceleration horizontally?
Acceleration. Yes, its acceleration is 0. And so how about B? 1.
Would it be v squared equals u squared plus 2as if we don't know the time?
V squared 2as. It calculates displacement. I think you would not, because 2as would become 0 because a is 0, and that would obliterate the s.
Okay. So does it need to be an equation without a in?
Could be. Is there anything else we could use? We want s, so it has have s in it.
So could we use the second one? So s.
U plus v over 2 times t. Yeah, that'll work. And in fact, I think we could use the two bottom ones as well. Ut plus a half at squared. And what would that become?
That'll be just s equals ut.
And how about the one underneath it?
that be the same? Because if a is 0.
Yes, and so s equals vt. And
Yeah.
basically, if it has no acceleration, then its initial velocity is going to be the same as its final velocity. It won't speed up or slow down. And so u and v are the same. And we tend to use this one, s equals vt. So if it's projected vertically, the thing you always know is that a will be minus 9.8. If it's projected horizontally, you can use s equals vt.
Okay.
Okay, so there we are, s equals vt. Horizontal projection. Okay, let's go for this.
Do we need to resolve the vector?
Let's see. You could, the magnitude and the direction. Okay, yeah, what would you get?
So that's 4 to the right and 6 up.
Mm-hmm.
Could we use Pythagoras?
Yeah.
So that's 2 root 13.
Okay. Oh, hang on. After 1 second.
So the initial velocity would be 2 root 13. So that's u.
Mm-hmm.
Do we know what v should be?
V. No.
Does that mean it should be negative 2.2 root 3? And
I believe A.
or is minus 9.8. And 2 would be 1.
T is 1. But hang on, the magnitude. So what are we trying to find?
We're trying to find v.
Okay, what do you get there?
Could we use v equals ua2 plus a2?
Yeah.
I got minus 2.59.
Yeah. V equals minus 2.59. And how about direction?
So that'll be meaning it's falling downwards.
Yeah. But would you know at what angle?
Could we work that out from the triangle?
We might. Let's think think about this thing. Okay, so you know the way. Let's do it in two separate ways. See how that goes. If we resolve horizontally, that will be S equals VT. The ball is thrown with initial velocity. So U is 4, which is the same as V. And T is 1.
Yeah.
And so what is S?
Just 4.
So S will be 4. And so after 1 second, its displacement will be 4. And then the other one, let's see. 2 root 13, was that 3.8?
I got 7.2 for 2 root 13.
213, 7.2. Okay, let's see. They did 4 plus 6. Oh, they did it all in one go. U plus AT. So 4 squared. V equals U plus A times T. That might be an even better way. V is equal to U plus AT. So V equals, so U was this plus AT, which is minus 9.8. To find the magnitude. So V is equal to 4i plus 6j. Ah, yes, so it's minus 9.8j for vectors, because that goes straight down.
Okay.
And so after 1 second, it is 4i minus what was it? 3.8. So 6j minus 9.8. Oh yeah, minus 3.8 j. And so that's how we can do this one. So you do that one for resolving horizontally.
Okay.
We said resolving vertically was 4. And so yes. And then we would have to do the Pythagoras for that. So what is the Pythagoras for that?
I got 1.23.
3, maybe meters per second. And how about the direction?
Would it be going downwards?
So they want the angle, this theta angle in the triangle.
Okay. Could we use the sine rule?
There's a simpler thing you can do.
Sokotoa.
Yeah.
Could we use tan?
Yeah.
So that's minus 3.8 over 4.
Mm-hmm.
So that's 10 minus 1.
Yes.
I got 43.5.
5 degrees. So it's going to have a speed of 1.23 meters per second at an angle of 43.5 degrees. They're saying 5.5. So 43.5 is correct. Did you do Pythagoras for 4 squared and 3.8 squared? Or did you put it in a did you put the minus in a bracket? So 4 squared, if you do plus and then in a bracket, minus 3.8.
Yeah, so it's 5.5.
5.5, yes. And so that one should be 5.5 meters per second. And if you don't put it in a bracket, let's say if it was going 4 to the left, and so we said it's minus 4, there's an error because you're trying to square root a negative. And it's because of BIDMAS. It's squaring first and then multiplying by minus 1. So it's giving minus 16 when actually what we mean is the square of minus 4.
Oh, okay.
And so, yeah, so just put any negatives in a bracket when you're subbing them in. Okay, so I think the trick for this one actually was saying that it's minus 9.8 that the acceleration due to gravity is j, because it's in the j direction, it's straight down. Any questions there?
No.
So let's practice another. Yes. Let's try this one.
So is that just 12 meters per second?
I believe so, but it's in the horizontal direction, in the I direction.
Okay. So do we need to find the height first?
The stone hits the height of the cliff. Yeah.
So we know u, because we know that's the vector.
Mm-hmm.
A is minus 9.8.
And what would that be in vector form?
Is that just minus 9.8 over...
I believe it will be 0 minus 9.8.
Oh, okay. And t is 5.
Yeah.
Because we use s equals ut plus a half at squared.
Yeah.
So for the first bit of the part of the equation, are we timesing 12 by 5?
We do it for the whole thing, I believe. So multiply both of them by 5.
So that would be 60 over 0.
Yeah. 60, 0.
So then you've got a half times 0 over minus 245.
Okay.
And if we times it by the half now, it would be 0 over minus 122.5.
Okay. What do you get?
And then do we just add them together? So it would be 60 over minus 122.5.
Yeah. $60 and minus 122.5. I got the same thing. And I did it. I was just using this simpler calculator. Is there no way for me to retrieve that? Oh, there is. Just take a screenshot of that as well. And so, whichever calculator you prefer.
Okay.
I'm sure there's probably some good way to do it in the other one. So that's a half times that. B 5 squared. You know what? Let's not mess around with it. And there we go. Hang on. What did they ask for? Oh yeah, they asked for the height of the cliff. And the speed of the stone. So this vector, so the height of the cliff, let's see. A stone is thrown over a cliff. The stone hits the water after 5 seconds. And so, which of these represents the height?
Is it 122.5?
Yes. And so because when it hits the water, it's at minus 122.5. That means the height is 122.5. And we actually had to find the speed at which the stone lands.
Can we do another equation, or is there another way to do it?
I think you'll just have to do another equation.
Could we use V equals U plus A2?
Yep.
So the U is 12 over 0. The A is 0 over minus 9.8. And then that's times by 5.
Yeah.
So the minus 9.8 times by 5 would be 0 over minus 49. And then add them two vectors together. So that's 12 over minus 49.
Yeah, and you don't have to say over. That would be for a fraction, just 12 minus 49.
Okay.
And so, how do you get what is the speed that it hits the water?
Do we have to do a triangle?
Yeah.
Is it 50.4?
50.4. And that's the Pythagoras of 12 and minus 49?
Yeah.
So that's 50.4. There we go, 50.4. And yeah, so this first one, you know the way we got 60 minus 122.5?
Yeah.
What that tells you is that when it falls into the water, it falls 60 across. So like there's a distance of 60 meters from where it was thrown from the cliff.
Okay.
How would you find the direction that it hits the water
at? We could use that as a triangle.
Yeah.
And we could use Sakatera.
Yeah. Which one?
Could we use tan again?
Yeah, and in fact, it will always be tan. It will always be arctan of it's always opposite over adjacent, so it'll always be the j over the I. Arctan of the j over the I for that one. Okay, let's try this.
So we knew U is 8i plus 11j. We're trying to find the displacement, so that's S. And we're finding velocity.
Yeah, we'll get S first.
Is our acceleration the same as the vector we used before, 0 and minus 9.8?
Yeah, so what is it in vector form? I and j?
0i, so it would just be minus 9.8j.
Well done.
And we know the time is 2. So could we use S equals ut plus a half a2 squared? So I've got 16i plus 2.4j.
Plus 2.4j. Let's see. And that would be meters. So that's it in vector form. What if they wanted the absolute amount in normal form?
Would we have to do a triangle?
Yeah, you would just do Pythagoras for that. But they just didn't say. Yeah, so S equals 16i plus 2.4j. So they They didn't ask for it. And then velocity is something similar. V is equal to u plus at, and you would just sub them in again.
Okay.
Any questions there?
No.
Okay, so let's just see. So then it's yes. Okay, great. So we got done what I wanted to get done. I just want to see something here. So the big picture is that so let's see what this looks like. Darts down horizontally. That's easy stuff. So I think the tricky stuff is the vector stuff, and so long as you take them, you can put them together, which makes it much easier. Just remember that A is minus 9.8j. If you're resolving horizontally, S equals VT is much easier.
Okay.
Because A is 0. And then it's just the same over and over again. And yes, when it comes back down, its final velocity will be the same as its initial velocity. If it's the same thing, same height, and when it, if you just consider what it is you're trying to find. So if it hits the ground and you start at 1.2 up, then when it hits the ground it's minus 1.2.
Okay.
Yeah, how was that for you, Eva?
That was good.
So projectiles is a huge thing, but we got the first 2 of it done. If you want, we can do it again next time, or we can do something different. Do you have any preference?
I think I might continue.
Okay. Any questions from me in general?
No.
All right. Well done, Eva. You did great, and I look forward to seeing you again next time.
Thank you.
All right. Have a good one. Goodbye.
Bye.
Right.